Question 7, part B. So we're going to let x be the number of red discs selected out of the 4. Now we want to find the smallest value for m for which the variance is less than 0.6. So this is a bit of a tricky question. It might take a little bit of understanding, so try and follow on. We know the variance of a binomial distribution, which this is, because we were given a number of trials for a probability of selecting a red disc, which is 5 on 15 plus m, and they will always be the same because the discs are being replaced. The binomial distribution formula for variance, so variance, we can find in our formula booklet. It's NP and then 1 minus P. You might have seen this before as NPQ. Q is just the opposite probability, so we can say it's just 1 minus P. So for our question, we want to know when this is less than 0.6. So let's substitute in what we know. N is 4, the number of trials, so it's going to be 4 multiplied by the probability of selecting a red disc, which is this fraction up here, 5 over 15 plus m, and then 1 minus this, well, we can do this over here, 1 minus 5 over 15 plus m, we can work out by making 1 15 plus m over 15 plus m. So 15 plus m over 15 plus m minus 5 over 15 plus m. So this will just be 15 minus 5, which is 10. So 10 plus m over 15 plus m. So it'll be 10 plus m over 15 plus m. If you got lost what I did there, I just changed this 1 to be the same common denominator so I could add or subtract to the top. So that's what my 1 minus p will be. Now this needs to be less than 0.6. So we can solve this a few ways. I'm going to use my calculator and I'm going to graph it. So let's get our calculator out. And let's go to our graph. So let's type this in. It's going to be 4 multiplied by, and it was 5 over 15 plus, and I'm going to use x instead of m, just because my calculator is used to using x's, and then multiplied by another fraction, and it will be 10 plus x over 15 plus x. So we want to know when this is less than 0.6, so I'm going to press tab and get a second line here of 0.6. And when is this blue line going to dip below the red line? So we might need to zoom out a little bit, so I'm going to change my window settings. So window settings, I'm going to change my x min to -5 and my x max to 15. And my y win, I don't need as much height here, so I'm just going to change this to -3 to 3. Okay. So it's going to intersect here. We can find that point. Menu, analyze graph intersection. And it intersects at 12.2. So m needs to be 12.2 for it to equal 0.6. So m is actually the number of green discs. So it can't be 12.2, it'll need to be the next value up, which will be 13. We don't round it to 12, because if we have a look at our graph, if it was 12, the blue line would still be above the red line. So it needs to be less than 0.6, and that was stated in the question. So I'll just find the intersection here. I'll write down using our graphics display calculator, m equals 12.2 ... Therefore m equals 13, because we need to go to the next value of m, so the variance is less than 0.6. And that's my answer to question 7.